Hi, this is Tejashwani. So we are from Group 8. Today we are going to present on the topic of neural networks models. So first of all, neural network models is nothing but a concept of machine learning. Which is used to interconnect nodes or neurons in the layer structure, and that resembles with the human brain. So here we are learning about the supervised model. So one of the supervised model is multi-layer perceptron. So here the perceptron is also known as MLP, so which is fully connected to the dense layers, so in the form of input dimension to the desired dimension. A multi-layer perceptron is a neural network, so which has different types of multiple layers like input layer, hidden output layers, and hidden layers. So which is used to create the neural networks to combine different types of neurons together, so that the outputs of some neurons will be the inputs for the other neurons also. So as we seen in this picture, which is placed beside of this, so in this multi-layer perceptron diagram we can see that there are three types of inputs, and those three inputs and the hidden layers has three nodes. The output layer, which of the one is added as an input layer to the hidden layers, and the hidden layer input is giving to the output layers, so which is used to produce the outputs of the functions which is produces. So in this type the multi-layer perceptron works. And the next, there are different types of advantages and disadvantages with this MLP layers. Like one of the advantage mainly used is to learn non-linear models also. So this MLP is used to create the non-linear models, and also which is used to learn models in the real-time practical partial fits. So as well as we also have the disadvantages, like MLP with the hidden layers have a non-convex loss function where there exists more than one local minimum, and therefore different random weights initializations can lead to the different validation accuracy. So we can have more than one accuracy present in the model, so which leads to the disadvantages, we can't find the correct output of it. So on next, the classification of the MLP model. So with what this algorithm used to classify the MLP model. So in this algorithm, we usually uses a propagation. So as we have seen in this code placed beside of this, so we just imported the MLP classifier from the sklearn.neural underscore network, so which is predefined function in the Python. So here we have given the input by using x and y variables, and then we used to produce the output of the functions by using hidden layers and output layers. So now after like placing all this algorithm, so we use it to train the models and create the labels for the new samples. And by this new samples is produced by using the clf.coef function, so which is predefined, which contains the weight matrices of different types of model parameters. So after this, the MLP uses a back propagation, as we have discussed earlier. So this back propagation more precisely trains some of the gradient descent and the gradient by using the different types of propagation methods. And next, this type of output function is classified by using the softmax function, and this is algorithm applied for the softmax functions. And next, regression. So the regression is one of the main topic in the MLP layer. So by using this regression, we train the back propagation with no activation function involved. So activation function is one of the function which we usually uses to train the output, like train the models and produce output layer. So here, by using regression methods, we are not using the activation function to determine the output layer. So which can also be seen as using the identity function, like which is similar to the activation function. Therefore, by this, what is the advantages is it usually uses the square error as a loss function, and then output is set of continuous values. So my friend Priyanka will continue after this.
Hi, my name is Priyanka. So, the next topic is regularization. As we discussed earlier, for both MLP regressor and MLP classifier, we use alpha parameter for regularization, and this is called as L2 regularization. So, this is basically used for avoiding overfitting by penalizing weights with large magnitudes. So a regression model which has L1 regularization technique is called as lasso regression, whereas if it's an L2, it's called ridge regression. The key difference is basically the between these two is the penalty term. For the regularization regression, which uses the L1 L2 regressor, it's called ridge regression, and this is the formula for that, where it adds the squared magnitude of the coefficient as penalty term to the loss function. And for the regulation, to vary the regulation in multilayer perception, we use alpha as a parameter as discussed. So alpha is basically used for a penalty term that combats overfitting by constraining the size of weights, and by increasing this alpha may fix high variance by encouraging smaller weights, resulting in a decision boundary plot that appears with lesser curvatures. Similarly, if you decrease this alpha, may fix a high bias, and potentially resulting in more complicated decision boundary. So this following plot displays the varying decision function with value of alpha. There is a visualization Python code which actually shows all these scattered plot. Next, I would like to discuss about algorithms. The MLP trains using three algorithms, which is SGD, ADAM, and LBFGS. So SGD is basically updating the parameters using gradient of the loss function with respect to the parameter that needs adaptation. The below the formula is used, and for ADAM, it's similar to SGD in a sense of stochastic optimizer, but it can automatically adjust the amount to update parameters based on adaptive estimates. LBFGS is a solver that approximates the Hessian matrix, which represents the second order partial derivative of the function. So from here, my friend Vivek will continue.
Hello, myself Vivek. Now I'm going to cover topics like complexity of algorithms, its mathematical view, and the practical applications. Suppose now I'm going to explain complexity. Suppose there are n training samples, m futures, k hidden layers, and each containing h neurons for simplicity and O output neurons. The time complexity of back propagation is order of n dot m dot hk o dot I, where I is the number of iterations. In, since back propagation has higher time complexity, it is advisable to start with smaller number of hidden neurons and few hidden layers for training. Now I explain mathematical formulation, and they have given some training sets of the for example, mm, one hidden layer and one hidden layer and one hidden neuron. MLP learns the function where function f of x is equal to w2g of w1 tx plus b1 of plus b2, where W1 belongs to RM and W2 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 B1 B2 belongs to our model parameters. W1 W2 represent the weight of the input layer and hidden layer. B1 B2 represents the base added to the hidden layer and the output layer. The binary classification function f of x passes through the logistic function. Uh, uh, this is the function given, and it is to obtain output values between 0 and 1. Instead of passing through the logistic function, it passes through the softmax function. This is the softmax function. Tips on practical use. Multi-layer is sensitive for future scaling, so it is highly recommended to scale your data. For example, uh, scale each attribute on the input vector x to 0 comma 1 or minus 1 comma plus 1, or standardize it to have mean 0 and variance 1. This is a sample code, Python code. By using importing standard scalar, uh, we imported this. Finding a reasonable regularization parameter alpha is best done using grids at CV, usually in the range 10. This is the range. We observed the LBFGS coverages faster and with better solutions on smaller datasets. For relativity large datasets, however, Adam is very robust. SCG with momentum or on the other hand can perform better than those two algorithms if learning rate is correctly turned. This is one of the question. This is the second question. This is the third question. Thank you.